We now determine if the given vector field f of x comma y equals 2x minus 6y times I plus negative 6x plus 10y minus 5 times of j is a conservative vector field. We say that f is a conservative vector field if f is a gradient of potential vector field f. If f is a gradient of this little f, so this f is the potential of f. Uh, Also, if curl of f equals 0, we say that the vector field f is a conservative vector field. And the way that we are going to determine this is by first considering this expression as f and then this expression as g. So first, let me copy this f. We have f equals 2x minus 6y, and then we have g equals negative 6x plus 10y minus 5. And to determine if this is a vector field, we have to see that if this equation is true, that is the partial derivative of f with respect to y, and this must be equal to the partial derivative of g with respect to x. So let's check this. Let me find the partial derivative of f with respect to y. And when I do that, I have to consider x as a constant. So I write partial derivative of f with respect to, this is with respect to, I'm sorry, y, and this equals the partial derivative of 2x is 0 because x is a constant, and the partial derivative of negative 6y is negative 6. Now let's find the partial derivative of g with respect to x. So when we differentiate with respect to x, we treat y as constant. So therefore, the derivative of 10y and derivative of negative 5 is 0, and derivative of negative 6x with respect to x is negative 6. Now we can see that partial derivative of f with respect to y equals negative 6, and this equals a partial derivative of g with respect to x. This is also 6. So negative 6 equals negative 6, and this is true. So we say that f is a conservative vector field. Okay, now that we have determined that f is a conservative vector field, so we can write f, this equals del f, where this little f is the potential field. So we have to determine f, and this means we can write down this capital F of xy in this form. That is, this is basically partial derivative of f with respect to x, comma partial derivative of f with respect to y. This is f sub y of x comma y, and this means f x is 2x minus 6y, and the partial derivative of f with respect to y is this expression. So let me write this. This is fx of x comma y equals 2x minus 6y, and also fy, that is partial derivative of f with respect to y of x comma y, and this equals negative 6x plus 10y minus 5. So to obtain this little f, that is f of x comma y, we have to integrate this expression with respect to x. So we integrate with respect to x, and when we integrate with respect to x, we have to treat y as constant. So therefore, the integration of 2x is 2 times of x squared by 2 minus the integration of 6y. 6y is a constant, and when we integrate with respect to x, we get 6yx. and then we also put the integration constant. We'll get some function of y. So I write down this c of y. Now let me integrate this f y of x comma y with respect to dy. That is with respect to y. So I'm going to put this with respect to dy, and this should also with respect to y. So let's do that. Here we have negative 6x, so it is negative 6xy plus integration of 10y with respect to y is 10y squared by 2, and integration of constant is negative 5y. We also put the function, its constant of integration as c of x, which is basically a function of x. Now we have to write this f of x comma y by combining these two expressions, that is this one as well as this one. So here we have x squared minus 6xy. First I write x squared minus of 6xy. Then we see that this expression is common in both of these expressions. So I just write this one, and I have to write the remaining terms. That is, this is 5y squared minus 5y. We now put this constant of integration as c, or we could also use this letter k. So we have determined this potential field f of x comma y, which equals x squared minus 6xy plus 5y squared minus 5y plus the constant k.